number, I'm mathematicious. It makes me so ambitious. My answers are judicious. Calculator never glitches. It's my mission. I get the answer right, and I'll be staying up all night just to check what I write. Mathematicians. What's a probability? Mathematicians. Mathematicians. When you're being inequalities. Mathematicians. Hold up. Check your work. Computing areas, quadratic formula, graphing parabolas. I think they're also.
Well, welcome to Algebra 1. This is the beginning of our lessons here for the subject of Algebra 1. And we're going to get into Chapter 1 today. So this is our first section, 1.1. And so in the first chapter, as we can see, we're doing Big Ideas Math, Algebra 1. In our first chapter, we are solving linear equations. There's 5 sections in this first chapter that we will go through one at a time. And so today we're doing 1.1. We're just solving simple equations in this lesson. And then we'll continue to go on and solving other equations in the lessons to come. So in 1.1, solving simple equations here, we are learning to solve linear equations. These are linear equations that we're pretty much dealing with most of the time in Algebra 1 is just linear equations. We'll see what that really means, but obviously you can maybe see even just from the word linear that it is describing a line. And so even just the picture of these equations, if we were to put them on a graph and make a picture of it, it would just be a straight line. So in this one, we're using addition and subtraction, multiplication and division to be able to solve these linear equations. All right, well, before we get into our lesson, I like to do a cartoon. So here's our cartoon for the day. This is a Far Side cartoon. It says, while vacationing in Africa, Pinocchio has his longtime wish to be a real boy suddenly and unexpectedly granted. Poof, he's a real boy. So apparently now he can die because the lions are right there in the middle. He's in the middle of those lions. All right, well, getting into our 1.1. So you have your notes from Big Ideas, the journal. And so you want to be able to see that these are going to be on the certain pages that we look at. So page 4, we will usually start with vocabulary if there's vocabulary that I think you should know. So on page 4, here's some vocabulary that you will see. And I underlined really what you would want to write down for these vocabulary words. The words are there on your page, on page 4 in your notes, but then you can write down what I've underlined there. So in an equation, you can write down a statement that 2 expressions are equal. It's a statement that 2 expressions are equal. A linear equation in one variable, there you can write down that it's an equation that can be written in the form of ax plus b equals 0. And that's where a and b are constants and a is not equal to 0. Otherwise, that would get rid of your variable here, because if a was 0, then x times 0 would still be 0. A solution of an equation really is a value that makes the equation true. So if we find a solution and we can plug it back in for the variable x, it would make it equal the number that's on the other side of the equal sign. So it's a value that makes the equation true. Inverse operations. Here's how we would solve equations. What do we do to solve an equation is that we use inverse operations, and really it is undoing certain operations. That's what you can see here. It's 2 operations that undo each other, and so we're going to be talking about what that would do and how that works out. So such as, here's an example, addition and subtraction will undo each other. So if you have an addition, then you would want to use subtraction to undo that. Equivalent equations. Equivalent, you can see it just starts off with like the word equal. It's just kind of like talking about equal. They have the same solution, in fact. They're equations that have the same solution. Those would be equivalent equations. They might look different, but if they have the same solution, then they are equivalent equations. Okay, so if you need to pause the video at this point before I move on, to just continue to write down what you need to write down there, you can do that. But I'm going to move on to our core concept that's found on page 5. So page 5 shows us the addition property of equality and subtraction property of equality. Now the word, We obviously know addition, subtraction, the equality part. That just means that you have to do it equally to both sides. So that's why it says you're adding the same number to each side of the equation. So you would just want to remember this golden rule of algebra, and you may have heard this before, that whatever you do to one side of the equation or equal sign, you do the same to the other. So just always remember that. You're going to use that the entire time. Anytime we were trying to solve equations, you have to use it always properties of equality, whether it's addition, subtraction, multiplication, division, or even other different properties that would, we would do something to both sides of the equation. So it's always equal. You always got to keep your equation balanced that way. So like on this one, it shows you have an equation of A equals a B. So you could add the C to both equations and it stays balanced. A plus C equals B plus C is balanced. So you just always do it. Whatever you do to one side, you have to do the same exact thing. So I'm going to add C here, got to add C over here. If I subtract C here, got to subtract C there. Okay, so now we come to page 6, and this says extra practice. And the extra practice is always going to be in our lessons the kind of example problems that we will go through together. Sometimes I might have you try some on your own and then have you check those. But we're going to continue to just always do those extra practice problems. So the notes will consist of the vocabulary, core concepts, and extra practice. So in this extra practice, it just says to solve the equation. It gives us 5 equations here. And I'm going to have to just do these first 5 because these are going to use those 2 properties of equality, just addition and subtraction. Let's just focus on those 2 for right now. So number 1, we have W plus 4 equals 16. Now I know you could probably just look at that and just, identify the answer of what W needs to be. So we're trying to figure out, well, what is W? But here it says to justify each step. You could say even check your solution as well. And even on that video at the beginning, it said check your work, right? We always want to check our work. We want to double check that we are doing things correctly. A lot of times that can be done mentally. You can plug it back in mentally. Sometimes it takes a little more thought or even scratch work to check your work. These ones will be fairly simple. But for this, we know we're trying to find out what the variable equals. The variable is the letter, and the letter could be different each time. W here, X, there's another W, we have a Y, we have a Z. It doesn't matter what the letter is, that's the variable. And so we're trying to figure out what that unknown is. That's what a variable is, it's unknown. Something we don't know, and so we need to, if we have an unknown, something we're trying to figure out, we could represent it with a variable. So when we actually do like a real life situation problem, we would want to represent the unknown part of that problem with our letter, with our variable, and you can use any letter to represent that. So here on this one we could see, well, what plus 4 is going to equal 16? I know we could probably just answer that. We might just know what number plus 4 is equal to 16, but I want you to get used to solving this step by step. So we want to undo this side over here, and so what we have is W plus 4. So where this W is, because the problem is, or the idea is that these equations are going to get bigger and bigger and bigger and bigger. These are very simple ones here, but we need to start on these basic ones, doing them the right way from the very beginning. So here's your letter. We want to get everything that's around this letter onto the other side. Get that letter by itself. It's called isolating the variable. Isolating just is a word that we use to talk about something being by itself, being alone. And so that's what we're trying to get, this W by itself on one side of the equal sign so we could figure out what it equals on the other side. So here, since it says plus 4, we're going to undo 4 with its opposite operation, which would be a subtracting 4. So we're going to subtract 4 from both sides. Now what that does is it will cancel out those 4s. You can even cross them out right now on your paper. And then we're going to see, if we're doing it to this side, we have to do the same thing to the other side. We have to subtract 4 from the 16. And then that would give us our answer, 16 minus 4, which we know is 12. And you might have already knew it was 12. You could have thought, well, I know 12 plus 4 is 16. So yeah, W has to equal 12. That's fine, but I want you to get used to undoing operations from your letters, because as it gets bigger and bigger and bigger with these equations, we need to remember how to do each step properly. So on number 2, we could say, and if you want to go ahead and keep working ahead, you can, but do it the right way here. So we got X plus 7. We want to get rid of our 7. So we need to undo this plus 7 by the minus 7. Do its opposite operations, because positive and negative, those are going to be opposites. So those can cancel out. It would make 0 here on this side. So that's why it cancels out, because those two make 0. Opposites always are going to make 0 here. And so we do the same thing to the other side. That's why it's the property of equality. So we're going to say negative 12 now minus a 7. And here's where you got to remember integers. So two negatives, when they're both negative, you have to add the numbers, keep it negative. So that's going to be 12 plus 7 for the numbers, but our answer is going to be a negative answer. So if you can think of a number line, you're going to go to negative 12, and then you're going to go negative 7 even further down the negative row. And so it's going to be a negative 19. So again, when you see two signs are the same, you're going to add and keep. That's different than when we get to two negatives in multiplication. So you got to keep those rules, those integer rules, separate. When we come to this one, here it's a little bit different, because now the negative 15 is in front of your W. W is positive, which is good. So here we want to undo negative 15, so its opposite operation will be to add 15 to it, so that those can cross out, become 0, and you're going to add 15 to the 6 over here. That's easy to do, just they're both positive, so 6 plus 15 is a 21, so it's 21. You can think of it as W would be 21. Negative 15 plus 21 is equal to 6, and that's really checking your work part. You could just mentally put that in there. You could put the negative 19 over here, negative 19 plus 7. Those are different signs, so you'd subtract, and that would become a negative 12. Okay, number 4, z minus 5. So we want to get rid of this minus 5. To undo a minus 5, we need to add 5 to it. So you got to do the opposite operation again, is adding 5. Opposite, this is minus, so you got to have a positive 5 here. That would make 0. Those are going to cancel each other out. That means you got to add 5 to 8, and so that's going to give you 8 plus 5, or 13. So you can again check, you can plug 13 in here for z. 13 minus 5 does equal 8. And then number 5, here's our y minus a 9. So we got to undo this minus 9, because again, we're trying to get the y by itself. So we need to remove this, and we're going to do to both sides, adding 9s. Add 9 there, that would cancel it here. Add 9 to the other side of the equal sign, where the negative 2 is, and those can combine. And we're going to take 2 away. They're different signs, so we're going to subtract these numbers. Take 2 away from 9, and our answer is going to be positive, because the bigger number is positive. It's a positive 7, so y is equal to a 7. All right, let's go on to the next kind of property. First, let's do a little joke of the day. I usually have a joke of the day kind of in the middle, just to break things up. It says, why is it so hot in a football game? Why is it so hot in a football stadium after a game? Why is it so hot in a football stadium after a game? Because all the fans have left. Wow, that's funny. All the fans have left. All right. Hope you enjoyed that joke. Okay, our next core concept. Back to page 5, we see the multiplication and the division property of equality. So this is where we're going to just multiply. Whatever we multiply to one side, we're going to multiply to the same thing to the other side. So if you times this side by c, you're going to times that side by c. This is dividing both sides. So if you divide by c on this side, you're going to divide by c on the other side. Now typically we see the division property more as a fraction. You're probably not going to see this division symbol right here show up. I'm not going to use that. I'm going to view it more in the way of like this right here. I would put a line underneath this, kind of a over c. This would be what I would be doing here. A over c. That means a divided by c. Your fractions are always the same thing as a division symbol. Your fraction bar here means division. So if I say a over c here, I got to divide the b over c on this one. So that's what we're going to actually really see on the division property of equality. Okay, so back to page 6 with our extra practice. So here now, these next ones, the 6 till a 9, is going to be using those properties with multiplication and division. So as you can see here, there's no subtraction or addition symbols between the variable and a number. What we have instead, like on number 6 there, is you have a 7 in front of your variable q. So this signifies or represents the multiplication operation. This means 7 times q. Whenever you see a number in front of a letter, that always means that those are being multiplied. Whenever you see two letters next to each other, so if I had A and B right next to each other, that would just mean A times B. So we don't have to actually show a multiplication symbol. You're never going to see an x anymore to show multiplication because that's too confusing with our variable x. You might sometimes see a dot in between things, that would be multiplication, or you might also see parentheses to show multiplication. So I'm going to show parentheses here when I'm doing some multiplication stuff. I'm going to show multiplication with parentheses. So in this case, we see it's 7 times q. So right now it's showing us multiplication, so we need to undo multiplication. Just like we were undoing addition or undoing subtraction, we now need to undo multiplication, and the opposite of that is division. So we need to divide both sides by the 7 to get rid of 7. And I'll show you why. So when I divide this side by 7, I'm going to, again, show it with a fraction bar. I'm going to put a fraction bar and then 7 underneath here. So this is 7q divided by 7. What happens here is these two 7s can cross cancel each other. They would become 1. Any number over itself is equal to 1. So now this becomes a 1q, which is essentially what we would want. We want 1 to be our number in front. So if I have a 1 in front of our letter, we're never going to actually see the 1. It'll just have the letter only. So now I'm going to do this to both sides, right? Because it's a property of equality. So I'm dividing this side by 7. I'm going to divide this other side by 7. 35 divided by 7 now. We know the answer should be 5. You just need to remember your multiplication rules as well. Because 5 times 7 is 35, so 35 divided by 7 is 5. Q is 5. You can check that by just plugging this in. 7 times 5 is 35. Correct. All right, let's come down to this one. 4 is in front of B. So it's telling us that 4 is being multiplied by B. So we need to undo the 4. And so we're undoing the multiplication operation with division. So I'm going to divide this side by 4. That way the 4s could cross cancel. They would become a 1, so I'd have actually a 1b. And divide the other side by 4. So negative 52 divided by 4. So if they are different signs, negative divided by positive, or even negative times a positive, it'll always be a negative. So our answer here is going to be a negative answer. We do need to remember our integer rules. And I'll kind of try to remind you of those as we go through, but you definitely want to know those well. Know those well, know multiplication as well. So negative 52 is going to, 52 divided by 4, so how many times does that go into 54? You can do that on the side. You can't even use a calculator if you want to, but this one's going to end up being 13, so we're going to see B is going to be a negative 13. So it is a negative answer because there are different signs as we divide or as we multiply, and then 52 divided by 4 is the number 13. Now number 8. So here we see Q is on top of the 11. Now remember what I told you is that this means division. So this is actually saying Q divided by 11. So we need to undo the division, and we undo it with the opposite operation of multiplication. So now we need to multiply both sides by 11 to be able to get the Q by itself. We don't want to multiply both sides by 3 because Q is not being divided by 3. Q is being divided by 11. So to do that, I'm going to show parentheses, put parentheses around this fraction here and put the 11 outside, showing I'm going to multiply this by 11. And again, I can cross cancel because this is like 11 over 1. You can use cross canceling there to get rid of those 11s. So now it'd just be Q by itself. And then we also do the same thing to the other side. So if we were multiplying this side by 11, we have to multiply the other side by 11 as well to keep the equation balanced. And so then 11 times 3 is 33, so Q is 33. We can again check that by putting 33 here. 33 divided by 11 is 3. That's correct. Always, you can check your work. It's always a good idea to check your equations. You can always make sure you're correct. This one here, we could see n is being divided by negative 2. So we need to get rid of the negative 2, undo the division by a negative 2, so which means opposite operations, multiplication by a negative 2. So we don't want to do the opposite sign here. We're not going to multiply by positive 2. We're still going to keep it negative. So if I multiply this by negative 2, the 2's will cross out, and then negative times negative will be positive. Our variable needs to be positive. So that's why I don't change the sign here. I got to keep it by the same sign. You're going to multiply or divide by exactly the same sign as it's showing here because we need this variable to be positive. So now I'm going to divide over here by the negative 2 as well, or not divide, sorry, multiply Multiply this side by -2, multiply the other side. That's the golden rule of the algebra. Do whatever you do to one side, do the same thing to the other. So now our n here is going to be a positive, because negative times negative is positive. It's going to be a positive number. 2 times 15, it's going to give us positive 30 for n. Okay, so that concludes this part of the lesson. That's just kind of just the equations, just a one-step equation part. And I know this should have been hopefully easy for you. If you had trouble with some of these integers and some of the rules, if you were forgetting some of the positive, negative rules, then you want to go back and review those. If you're having a hard time with some of the multiplication, then you want to go and review your multiplications. Well, you definitely want to know how to multiply all the way through your 12s, definitely. But you might even want to go a little further and go all the way up to the 15s, because that might be handy to have as well. But now we're going to switch gears a little bit and go into some kind of more problem solving. You're going to see more word problems, because we can apply these to the word problems. And these were just one steps. Eventually these are going to get more difficult. We're going to actually put the properties together. You're going to be doing 2 steps eventually, 3 steps, and multi-step equations. So we want to always make sure that whatever equation you have and that you're trying to solve, you identify where your variable is and what you need to undo that's around that variable. And there's definitely is a certain right process to doing that. In this one, there was just the one step to do, but as you get to more steps, we have to do that in the right order of our steps, and we'll see what that is when we get to those. But first, we're going to look at this 4-step approach to problem solving. So when we come to a word problem, and you got to read out, maybe a little paragraph that it has for you, and this is right there on the top of page 6. So as you look at that in your notes, you just want to kind of remember these kind of 4 steps there to solving those word problems. And number 1, you want to first just understand the problem. You want to understand what is the unknown. That's going to be where your variable is. What is the unknown in this problem? What information is being given? So there's definitely going to be some information given in the problem. And then definitely what is being asked. What do you need to be, what are you being asked to find typically? So that's what you always want to know. That's usually the last part of the problem. Is it's always a question. Find this, or what is this? That's going to be probably the last part of that paragraph. So once you understand that, you might want to need to read through that more than once to be able to do that. Then you want to go to number 2, make a plan. Figure out a strategy that you want to do, and there's actually some problem-solving strategies on the next page, it says here. So we'll look at those in a little bit. One of those strategies is, and probably the most popular one, is just an equation, to actually write an equation, just like we were just solving. Because if we can write an equation, we can solve the equation. And that's what number 3 is. You want to carry out your plan. So if your plan is to write an equation and you write one, then you want to carry it out by solving that plan. Write the equation, solve the equation, and it says check that each step is correct. So as you're going through, just make sure your steps are correct. And then the last one, number 4, is once you've got your answer, you can look back and just examine this and just check your work, really, what you're doing. Check your solution that it makes sense with the original statement of the problem. You want to definitely see that this is going to make sense. Does this answer make sense to what the problem's asking me? Because so many times students, get this far off answer when that answer shouldn't make sense to what they're being asked. So that should be a clue. Wait a minute, I did something wrong. I got to go back and look at where I might have made a mistake as I was solving this equation or as I was carrying out my plan. All right, let's try a couple. Okay, so here is that common problem-solving strategies, and this just gives you like kind of a list here to make, kind of put it all there on one page. It looks like there's 10 of them. So, like I said, the one that we'll probably use the most often is write an equation, but sometimes you might even just use the guess, check, and revise strategy. Definitely you can sketch a graph or a number line. Sometimes that could be a strategy to help you. You can make a table, like a table of values, those kind of things. Make a list, look for a pattern. Sometimes is also helpful, drawing a diagram. Working backwards can also be a strategy to use. So these are strategies you can definitely use. But like I said, writing an equation is going to be probably the most popular one that we do use. So as we look at our next ones here, number 10, it says a coupon subtracts $17.95 from the price P, so they already told you the price is the variable P. There's your unknown. Remember we talked about you got to identify what your unknown is. We don't know the price. So the price P of a pair of headphones. It says you pay $71.80 for the headphones after using the coupon. That's some expensive pair of headphones. Write and solve an equation to find the original price of the headphones. So it tells you what to do again here. So again, remember, understand what's being asked. So understand what the unknown is. The unknown is the price. What is some of the important information? Well, it tells you how much the coupon is and what the coupon does. It subtracts it there from the price. It also tells you how much you paid total for your headphones. And then what are you being asked to do? You're asked to write and solve an equation to find the original price of the headphones. You're trying to find that original price of the headphones before the coupon. And so we would say, okay, the price minus the $17.95, you could start there, just P minus $17.95, because what that does, it says that coupon subtracts the $17.95 from P. So P minus $17.95 is going to equal the price you pay. So you're paying $71.80. So there's our equation. We wrote the equation. It's just going to use a little addition property of equality. We just got to add this $17.95 to both sides to solve for P. So that's what we wrote the equation. Now we're solving the equation. So that cancels these out here. We're going to add $17.95 on this side as well. So again, we can add down. That's going to give us 5. This is going to give us 17. So it's going to be 75 cents here. We're going to carry a 1. And so we got 7, 8, 9, and then 8. So 89, looks like it's 89.75. So that would be our total price. Our original price of those headphones was $89.75. All right, number 11 says after a party, you have 2/5 of the brownies you made left over. Okay, well, good for you then. You get some more brownies. There are 16 brownies left. Okay, there you go. You got quite a bit of brownies still to munch on. How many brownies did you make for the party? So that's the question there. So again, what is the unknown? So that's our first idea. We're trying to understand the problem. What is the unknown? So it says basically the unknown is the number of brownies that you originally made, your original number of brownies that you had for the party. That would be your unknown. What's the important information? It tells you you have 2/5 of that number left. So 2/5 of that you have left over, and how much do you actually have at the end? How much total brownies left over? It tells you that's 16. What are you being asked? You're asked to find the original number of brownies you made for the party. So we write an equation again. So that's our strategy we want to do. I would just continue to use the same strategy with writing an equation. So if we use B for brownies, use B for the letter. So 2/5 of B. The word of would always show you multiplication. That always means to multiply. You may want to make a note of that. The word of in a problem will always mean multiply. So 2/5 times B. That would give you the start. So how many brownies is what we're trying to find? Again, that's what we're trying to understand. So we chosen to write an equation. That's, basically figuring out a plan. Carrying out the plan now is you write that equation. 2/5 times B, just put it right next to each other, 2/5 B, it's equal to 16. That's how much brownies are left over. So there's our equation, 2/5 B equals 16. So we now need to undo the 2/5. So here's where we have a fraction. So we're going to do this in 2 stages. First, we're going to undo the denominator, then we're going to undo the numerator. So the first thing to undo the denominator, since it's on the bottom of the fraction, it's like division, divided by 5. So we want to first multiply both sides by 5, so we can cross cancel our 5s here. Multiply 16 by 5 on the other side. So now 16 times 5, if you don't know what that is, you can use a calculator or just do some scratch work to do those. That's going to give you 80. So now we have 2b, okay, we got rid of our 5 on the bottom, now it's just a 2b on this side is equal to 80. So now we need to get rid of the 2, and 2 is multiplying b, so we want to divide by 2, just like we were doing before when we were solving those equations earlier. So divide by 2 here, that would cancel our 2's out here, leaving just with b, and then 80 divided by 2, we should understand that's going to be 40, right? 8 divided by 2 is 4, with a 0. So B is 40. So the original number of brownies that we had for the party, or you made for the party, was 40 brownies. Now you might want to put the word brownies next to this, 40 brownies. That's typically what you do. Now I want to show you one more way we could have solved this. Since we have a fraction, this is a kind of a simple way to do it. You can do this all in one step though. I did really this in 2 steps. I first divided by 5, then the second step I multiplied by 5, then I divided by 2. But I could do this all in one stage or one step. Let me show you that. I'm going to write the equation again over here on the side. So that's our 2b equal to 16. What I'm going to do is I'm going to cancel both numbers out at the same time by just multiplying by what we call the reciprocal. That should be a familiar name to you because we use that to divide fractions. Divide by the reciprocal. So we're going to take the reciprocal of this, which just means to flip the fraction upside down. So instead of 2/5, I'm going to multiply by 5 over 2. So multiplying by 5 over 2, the 5's cross cancel and the 2's cross cancel. And now I got to do the same thing over here. I got to multiply 16 by 5 over 2. Whatever I do to one side, the left side, I got to do the same thing to the right side. Now I'm going to put the 16 as a fraction. I'm going to put that over 1. Anytime you want to, you can put a whole number over 1. That kind of makes it a fraction. So now we can see we're going to cross cancel 2 and 16. 2 goes into 16 8 times. So that can become an 8. And now we just multiply across the top. So 8 times 5 is 40, and this would be 1 times 1 down here. So it's going to be, B is going to be 40 over 1, which is the same as 40. So we get the same answer, but this one's doing it in one step with multiplying by the reciprocal, where this one did it in 2 steps. So if you can understand this and you prefer doing it this way, then that's fine. You can do it in the one step of multiplying by the reciprocal. But if you like this way, this might just be an easier way just to do it in 2 steps. That's how you'd always get rid of a fraction in front of a variable. So if you ever have a fraction in front of your variable and that fraction is multiplying the variable, you can do it in the 2 steps like this side, or you can do it in the 1 step over here with multiplying by reciprocal. All right, so that concludes our lesson here in the 1.1, and then I'll see you again on the next one.